Alright, so this is going to be our tutorial on how to use our formula sheet for the beginning of Chapter 7, so the first half. So in Chapter 7, we're going to talk about all of these solids that are found on page 2 on the left-hand side. So we are first going to start with the rectangular prism, then we'll talk about the prism, and then talk about the pyramid. So rectangular prism, it looks like a box or a file cabinet. You're going to have 3 numbers associated, so you usually represent them with length, width, and height. You can plug them in to any part. So just because I call something the length doesn't mean that you can't call that the height because you're thinking of it turned the other way. Even though you should use the way it's oriented, sometimes they can be a little bit confusing. So we should get all the same answers as long as you use each number twice. If you get a very large answer for your surface area, just be careful. Notice that there are plus signs in the middle, so just be careful there. Okay, the volume is just length times width times height, so you're just multiplying them all together. Usually when we do a rectangular prism, we also find the surface area to volume ratio. The reason why we do this is because we can think about making things. If you make a can of soda or a water bottle, there's tons of different shapes of water bottles right now. Usually, unless it's a marketing strategy, you want to have the lowest surface area, meaning the lowest amount of materials, with the same amount of volume or liquid inside. Okay, so for us, we are not having meaning behind them quite yet. So our surface area to volume ratio may be a proper fraction or an improper fraction, but you should leave it as a fraction and it should be in reduced form. Okay, the next shape is just a normal prism. So the one I have pictured is a regular shaped prism, regular polygon shape. They can vary, so I have a hexagon pictured. It could be a pentagon, it could be a nonagon, an octagon, basically anything. So, a couple things. When we are looking at our regular polygons, we have formulas on our formula sheet of those polygons. So if we just flip to page 1 of our formula sheet, the regular polygons are going to be right here. Okay, so we are going to use those formulas. A reminder that the lowercase a is the apothem, B is now our base edge for our prisms, and we are just going to plug in. So when we shorthand, we did perimeter equals n times b, number of sides is just our n, b is our side length. Our area formula is 1/2 of that apothem times your perimeter. Okay, now, where it gets more interesting in prisms is when you have, let's say, a right triangle for a base. Okay, so it's not always going to be the regular polygons. It might be a regular triangle. It could be an equilateral triangle. It could be a right triangle. So, things we need to think about. If it's an equilateral triangle, we are going to have to find the height unless we are given the apothem. So, you can either find the apothem using special right triangles, or you can find the height using the Pythagorean theorem by splitting our side because the apothem is going to split that side. More likely you're going to get a right triangle and you are going to solve for one of the missing sides using the Pythagorean theorem, and it'll be very straightforward. Then you are going to plug in to your area of a triangle. So don't forget that you have other area formulas. Okay, so if we go back, once we get our perimeter and our area of the base, we can just plug in to our lateral area, which is the perimeter times the height of the prism. Surface area, after we find the lateral area, we're going to add 2 area of the bases. And then our volume is just the area of the base times the height. Okay, and that height is of the prism. It gets kind of confusing when you have a right triangle and you have the height of your triangle also. So make sure lateral area, surface area, volume is all of the prism. And then the last one is going to be our pyramid. So our pyramid, we're going to start with the Pythagorean theorem because we have a right triangle. L squared equals h squared plus a squared. Okay, so we're going to start there, and then we're going to do the same thing we did for a prism. So we're going to find the perimeter of our base, our area of the base the same exact way, and then we're going to plug in what we know. Okay, so lateral area is 1/2 of our n, or our number of sides, times our base edge, times the slant height, which is our L. Surface area, we're going to take that lateral area and add only one area of the base because we are now have the vertex at the other side. And then our volume, we have 1/3 area of the base times our height. Okay, remember your bases are going to vary. So this is the hardest one, meaning it's a square base, and the hardest because it does not tell you what your apothem is. You have to figure it out. So if we think about a square, it is the same length all the way across, and we know our apothem starts at the center. So we can find our apothem by just taking our base edge and dividing it by 2. Okay, so that is 7.1 through 7.3. I hope this is helpful. Thanks.